Okay, our asteroid impact unit is an engineering unit that ties what we know about rocks and minerals to the real world. So we're actually modeling an engineering project with using what we know about rocks and minerals. So our first target is describe characteristics of a mineral. Now we've talked about rocks before. We haven't really talked a whole lot about minerals. Remember, minerals are what make up rocks. Okay, so what are some physical properties of minerals? Your essential question today. All right, so a mineral is a naturally occurring inorganic, meaning it's not made of living things, has a crystalline structure. So that means the atoms bond in a certain way to form a crystal structure. And naturally occurring means we find it here naturally on Earth. It's not man-made. So physical properties of minerals. One of the most well-used physical property, one of the best physical properties for a mineral is density. Remember, density is how heavy something is. Density is mass divided by volume. Remember the broken heart example. Water has a density of 1. If it sinks in water, the density is greater than 1. If it floats in water, it's less than 1. So this picture below kind of tells you about the different densities. Okay, 1 kilogram of cabbage for a 2-liter bottle is 0.5 density. Okay, 1 kilogram of cabbage in 1 liter is more dense, so that has 1. So when you look up minerals and we try to find out which minerals are in a rock, minerals have different densities. So we can figure out what minerals in a rock based on the density. Another physical property for minerals is how hard a mineral is. We use the Moss hardness scale to determine how hard a mineral it is. It scales from 1 to 10, 1 being the least hard, 10 being having the greatest hardness. Diamond is a mineral that has the highest hardness. It's a number 10. So when you look at the scale, pretty much we do a scratch test to tell how hard a mineral is. And here's the scale that we use, the Moss hardness scale. Okay, so if you can scrape a mineral with your fingernail, then it has a hardness of 1. And that mineral is usually talc. Now, are there other minerals that have a hardness of 1? Yes. But these are just the most common ones that have this hardness. If you can scratch it, it takes a little bit harder pressure to scratch with your fingernail, then you're at a 2, which is gypsum. If you can scratch the mineral with a copper coin, then you've got a hardness of 3, which possibly could be calcite. If you can scratch the mineral with a steel knife, okay, then it's a 4. You usually have maybe fluorite. If you can scratch it, but it takes more pressure to press down with a steel knife, that's a hardness of 5, the mineral apatite. If you can scratch with a steel file, then you've got a hardness of 6, which is orthoclase. If you can scratch with glass, hardness of 7. Quartz. If that mineral can scratch quartz, you have a hardness of 8. If you have a mineral that can scratch topaz, which has a hardness of 8, you have a hardness of 9, which is corundum, which we find in sapphires. If a mineral can scratch a sapphire or a corundum, then you have a hardness of 10, which is a diamond. So that's usually what we do is a hardness scale. We do a scratch test to find the hardness of the mineral, which you will be doing in one of your labs. Okay, another property of a mineral is luster. This is how reflection of light on that mineral works. You usually have classifications of metallic, non-metallic, virtuous, or glassy. So metallic luster means that the mineral reflects light very well. So it appears really shiny, like this mineral right here. A non-metallic, I don't have a picture of that one, but a non-metallic luster means that the mineral does not reflect light, so the mineral looks kind of dull. A virtuous luster is kind of a glassy luster, which it pretty much looks like glass. It's not as shiny as metallic, but it looks pretty much like glass, so it's called virtuous. You do have what's called a resinous luster. Basically, it looks like there's a lot of resin. You can see particles in the mineral, and that's that picture right there is a sap. That's sap. Okay, and then other colors or other properties of minerals are color. It's not a good identifier because minerals come in a lot of different colors. So, for example, quartz, it's a mineral. It can come in so many colors. It can come in clear, green, pink, kind of a purpley blue color. So color does not help us really define what mineral you have, but it is a property of a mineral. Streak is the powder or residue that's left behind when a mineral is scratched. Now this is a somewhat pretty good, but however some minerals have the same color of streak. So it could be good and it could be not so good if another mineral has the same color streak. Pretty much what you do is you take a mineral and you rub it across a porcelain plate and it will leave behind a residue, and that's called the streak. So cinnabar leaves behind a reddish color. Pyrite leaves behind a dark, kind of dark gray color. That's how we can kind of distinguish pyrite from gold. Gold leaves behind a more gold color. Or actually, pyrite I think is more green. I think that's color should be green. Okay. When you break a mineral, it breaks in a certain direction and makes certain shapes. That's called cleavage or fracture. So this picture shows you what forms, like if they break in a cube form, octahedral, I can't remember how to pronounce that last one, dodecahedral. Okay, these are all different shapes that minerals can break in, but do realize that minerals can break in the same shape. And then another property of a mineral is its crystalline structure. This is the shape and size due to atoms, how atoms arrange to make those minerals. The shape and size is dependent on that. Okay, there is something that also is dependent on that, temperature. The size depends on temperature. So if you increase the temperature, then you're going to have a larger crystal growth. That's why when we dig down deep in the Earth's crust, we find larger crystals, because they're under immense temperature down beneath the Earth's crust. Crystals can grow bigger. And that's why we have to mine for like diamonds, because we want to get down as deep in the crust as we can, where there's a higher temperature. It makes bigger diamonds. Also, if you increase the time, it'll increase the crystal growth. So if crystals have a longer time to grow, they're going to get bigger. So this just shows you kind of the size of some crystal growth compared to larger sizes. So these were also had increased time and temperature to grow larger. So a little bit smaller. And last but not least, we're going to be looking at rocks that are a collection of minerals. So minerals are basically compounds of matter. So they're made up of elements and atoms. And when you add those compounds together, they form a rock, which is a collection of minerals. You can almost think of it as like a mixture of minerals. Okay, so you're going to get a lot of practice with using the properties of a mineral. And you're going to be able to classify a mineral based on those properties. So that is target 36.